Hello guys, and welcome back to Joe's Ventures. And today we're going to be doing part 153 of our Planet Zoo mod spotlights, where we take a look at some of the wonderful mods people have been making and use them to talk about some of the wonderful biodiversity that we share our world with. So today, as I mentioned in the last one, we do have a few very interesting kind of exhibit animals. And we've got a primate and a few extinct animals that I know you all are going to love. I've kind of already covered them at least before in other mod spotlights, so especially in Jurassic World Evolution 2, one fairly recently. You'll probably see over there somewhere. Anyway, we'll get started. So the first three mods, little exhibit mods, Scott has really come back and jumped in with those. So we're going to have a look at first the Chinese redheaded centipede. Let's have a look at these guys. So that's not what I want to look at. I wanted to look at exhibit camera. So here's one there. I want to find one on light. Just hanging out there. If you'll find one on the light. He's in the log, I guess. There he is. I think this is as close as we're going to get. But anyway, here is the Chinese red-headed centipede, or known as the Chinese redhead, or Scolopendra mutalens. These are a centipede from East Asia, with the type locality being Japan, that averages about 20 centimeters, or about 8 inches long, and lives in damp environments. So in ancient Chinese traditions, this centipede is actually used for its healing properties. So placing it on its hair on a rash or other skin disease is said to speed up the healing process. And the roasted dry centipede is pulverized and used in Korea for treatments of back pain, falcons, and sores. And they're also been known to harboring little aggression to other centipedes, which is actually quite rare among giant centipedes, and can be kept communally. Antimicrobial activities of the identified compounds were reported around gram-positive and gram-negative bacteria, fungi, viruses, and parasites, explaining why these guys can actually survive in quite polluted environments and harsh environments. So females are incubator mothers, so they actually guard their eggs by wrapping their body around the clutches until the eggs hatch. And another way to tell them apart from subpinnipeds is spination of the pre-femur on the ventral legs, ventrally, dorsally, and medially. So one thing that's really famous about centipedes is their venom. So the venom of centipedes remains largely unstudied, and the components are largely unknown, but they seem to contain small toxins that can use causing a local burning pain, and have been toxic to mice and induce platelet aggregation, so kind of make them grumpy. And the biological actions of these toxins in centipede venom are mostly unknown, and there have been some research trying to figure them out, but I'm not going to get too much into the weeds there. So as I mentioned, a little bit is known as the venom apparatus. So the venom glands between the cuticle and the epidermis would turn outside out. So they have actually muscles between these secretory units that kind of use them to ejaculate the venom into a bite. And it's quite unique. The venom contains a few different enzymes that's very different from other arthropods, where meloprotease, which is an enzyme that breaks down protein, is an important role. And these venom have effects on skeletal muscles, heart muscles, and neurons. And the effects are attributed to larger proteins in the venom. So there's actually like some neurotoxins that allow them to kill prey, because these guys are large carnivores, and they'll eat large things, as we'll get into. So like other centipedes, they are predators, so they'll inject venom into their prey, and venom is injected to immobilize and break down tissues. And they feed on many sorts of live animals, and plant matter can be occasionally consumed. So these are highly selective, and they tend to bite the thorax or head instead of the abdomen, so that when they try to bite. And if the bite was made on the abdomen, they usually reposition and strike again on the head or thorax. So they typically try to go for the head, like Thanos. Research on these behaviors has suggested that the reason the centipedes were repositioning their prey to enhance the speed of the neurotoxin was arrived, so they actually just allows their toxins to act faster. And two other concepts have been suggested for this prey orientation, and it suggests that it's expensive to produce, so they got to make sure they use as least as possible. And other components suggest that striking the prey in a specific position will allow the centipede to restrain it until the venom can take effect. And being centipedes, they can eat pretty much anything smaller than them. So behavioral studies actually found that when centipedes are attacking the heads, they will counteract using the forbicles, and then if they attack the rear, they will adopt a warning position and use their last pair to kind of fake it, to make it look like they're attacking the head, which is quite interesting. But yeah, these guys are quite important actually for the use of traditional medicines. As I mentioned, they've been used to treat various medical issues like strokes, convulsions, lumps, joint pain, poisonous tumors, and snake bites. And there has been some kind of looking into that research, like cancer research. They've been looking into, since it's been used for cancer treatment historically in traditional Chinese medicine, there has been research looking into the compounds in its venom that could be used to potentially kill cancer cells, and also antimicrobacterial or microbial. So they actually is something that can use to sterilize different things, and also food for medicine, allergens as well. They can cause allergic reactions in the centipede bites, but we don't know about how that does that. It's just one of those complicated medical things. But yeah, it's still quite cool that this little guy, this little centipede animal that looks, people think, oh, gross and ugly, has so much medical potential, and has had medical potential, and used for medicine, things like that. So yeah, that's quite cool. So that's the Chinese redheaded centipede. Now we're going to have a look at another close relative, also done by Scott. This one's relatively new, so I won't talk too much about him, but we've got the Philippine mint-legged centipede. So let's have a quick look at this guy, so you can see what this guy looks like. How beautiful is that? You can see those beautiful colors. So yeah, they're not too different from other centipedes, and their scientific name is Paradoxica, and they were only recently described in 2018. We'll have a look in here to see some of the information. So this was described from the Philippines, so they are found in the Philippines. And one thing that sets them apart from a lot of the species, because there's about 700 or so species in Scolopendra, there's a couple species, as this species as well, Paradoxica, has been observed being semi-aquatic and can be found resting fully submerged underwater, which is rarely seen in centipedes, so it's quite a special one. The first specimens to be described were occurred illegally. Due to this, not much research has been done on these guys, sadly, so there's not much information. So most things we know about these guys comes from other centipedes. And there seems to be two color morphs. So both have the mint color legs, but one has a dark body and the other has a lighter banded body. I don't know if it's represented here. We might have a quick look. But as we may generally talk about the centipedes and the specific venom, as we kind of talked about that. But we'll have a look and see if we can see the different morphs. So you can see that kind of orange band, but there's also a kind of dark band going on. I think this is just meant to represent the orange band individuals, but you can't tell me that's not such a pretty animal. And they are available, I believe, in the pet trade, so you can have a few if you live in the right places. And I know some people probably try and scam you, but it's all good. Really, really cool anyway. Really love these guys. Definitely a really awesome mod. I really love, we just get so many cool exhibit animals from Scott. He does a great job. But yeah, that's the Philippine mint-legged centipede. Now we're going to be moving on from invertebrates to amphibians. Last one's also done by Scott. We've got Tiger's tree frog. So let's have a look at these guys. So look at that cute little guy there. Let's see if we can find another one sitting on the... Oh, he's beautiful. Look at this beautiful guy. He can sit there. Look at how amazing he is. Anyway... So this is Hydralistus tigrinus. So these guys are a species of tree frog native to Colombia and Ecuador, and can be found in elevations from up to 3,000 meters up in the Andes Mountains. And scientists have observed the frog sitting on vegetation, approximately about half a meter off the ground. And we'll talk about that they're actually endangered. So they're a medium-sized frog but robust. They're quite a powerful but medium-sized frog with spots covering various parts of their body. Typically, the adult male frog measures about 54.2 to 60.7 millimeters in length, so about 5.4 to 6 centimeters, with the adult female being slightly bigger, but about 62.9 to 63.2 millimeters. So still a little bit bigger. The irises, you can see the eyes are kind of grey with black stripes or black reticulations. The skin of the frog on the head, back, and legs are yellow-green. So you can see the yellow-green there, but they've got the stripes or bars that extend towards the belly, which is similar to tiger stripes. So kind of where it gets the name the tiger's tree frog. There are also orange spots on some parts of its body, and the bottoms of their feet can be grey in colour, and the parts of their climbing discs, so the little climbing discs they have on their little fingies there, can be black. And this frog's distinctive pattern allows it to be distinguished from other species in the genus of Hylostrictus. And this is also why the species was named, because it has similar patterns to that of a tiger. So that's where it kind of gets its name from. So yeah, another really, really cool species of frog that we get to talk about. And another great mod by Scott. He just absolute bangs out all these wonderful mods. Just absolutely wonderful. Anyway, we're going to move on. So next up, we've got a monsoon mod. How can you not love a monsoon mod? Next up, we have got the East Javan Langur. So we'll have a look at these guys. We've got a couple colour morphs that we'll have a look through, so that's quite interesting. So we've got the East Javan Langur, or Tradopithecus anataris, also known as the Ebony Langur, the Javan Langur, or the Javan luting. These guys are an old-wheeled monkey from the Colobine family. So you can see they're mostly common glossy black with a brownish tint to its legs, sides, and side burns. And it's mostly found in the island of Java, as well as the central surrounding islands. And the Latin word atrasis means golden, refers to the less common variant. Note that the common name golden langur is used for different species. So we're actually breaking the trend a little bit. So these are the more common variants, with that real dark colour to them. But we've got a lot of orange ones here, so we'll have a look at the less common one at the moment, because it's a little bit more striking. And I just have to say, before I carry on, Monsoon has done an absolutely wonderful job with that hair. It really makes it look wonderful. It really just gives it a lot of a pop to it. He's really done a wonderful job. Anyway, like all langurs, the species have notably long tails, measuring up to 98 centimeters, or just under a meter in length, while the body is only about 55 centimeters long. The two subspecies of this monkey are fairly similar in appearance and are geographically separated, with males and females both usually glossy black, although the female's has a pale yellowish white patch around the pubic area. And juveniles of both subspecies are orange in colour. The dominant subspecies has a rare morph where it does not lose its coloration when it matures. Instead, its coloration darkens slightly with yellow tinges on the side, around its ears, and a black tinge on its back. So you can see these are the ones with the rare morph, the glossy black with the tinge. So you can see that's where it kind of comes from. In terms of its habitat, like very other types of langurs, they tend to inhabit interior and peripheral areas of the rainforests, and they are I can't speak today. They are diurnal and arboreal, so they can be found in the trees and out during the day. Their diet's also primarily herbivorous, so they typically feed on leaves, fruit, flowers, and buds, or that they will eat insects larvae. And like other colobine primates, they have evolved a stomach that's specialized for dealing with plant matter, also more efficiently. And they also have enlarged salivary glands to bring up more food, which is quite interesting. You can hear an ice cream truck. Like other species of langur, they are also quite social. We'll have a look at the babies as we talk about the juveniles a little bit. Like other langurs, they are social animals and can live up to groups of about 7 individuals, with 1 or 2 adult males in the group, although they will look after the offspring of other mothers, from other mothers, as well as their own. Adult females are aggressive towards females from other groups, so they take care of their own pretty much. If they've got your group there, they will take care of your babies, but if there's another outsider comes, he's like, nah, I'm not dealing with that. The brighter colouring of juveniles may alert females to their presence and ensure they'll always be noticed and protected. And the species typically has no discernible mating season and produces probably about 1 offspring or so at a time. So as I mentioned, there are 2 subspecies. So this is the subspecies, the dominant subspecies would be Tradopithecus atrasaurus, or the Eastern Javan langur, or the Spangled Ebony Lutang. And the western one is Maturnus. And a Maturnus was also, in 2008, actually elevated to its own species, the West Javan langur. So it's kind of depending who you ask, but most of the time I think they're actually considered other species these days. You can see the differences between these guys, and just love these mods. We'll have a little look at the black one as he sits over here. Really, just with the hair, Monsoon has done a wonderful job with the hair and really makes it look wonderful. Alright, so that's the East Javan langur done by Monsoon. Last one there. So next up, we have got Teleoceras, which is an extinct rhino, done by Leaf and Nicholas Linerider, who's actually bumping out a lot of extinct species recently, which is quite cool. And Leaf probably did the coding as well, because Leaf's quite good at that. So we can have a look at these wonderful guys. So let's spot the male first. So here's the male. So Teleoceras, which means perfect horn, is an extinct genus of rhino. So it lived in North America during the Miocene and Pliocene, so between the Hemiforgian and the end of the Hemophilian period, from about 17.5 to 4.9 million years ago, so quite long-lived. And they grew up to lengths of about 4 meters long, so quite huge animals. So they went extinct in North America along as coleops at the end of the Hemophilian, likely because of rapid climate cooling, increased seasonability, and the expansion of these kind of seafall grasses, as isotopic evidence suggests that these uptakes were their uptake of these grasses were far less than horses, so these guys were most likely browsers. The grave fossil site in northern Tennessee, dated about 4.5 million to 5 million years ago, hosts the largest known populations of Teleoceras. And there's a few different species described, but I don't know how they'll actually stand the test of time. So I think these guys are actually a little small. I don't know. Let's see how big they say they are. So it's about 4 meters long. So yeah, they are a little bit small for Teleoceras. I think the size needs a little bit of an update, but they are still quite big. The Teleoceras has much shorter legs than modern rhinos, you can kind of see there, and quite a barrel chest, and they're built more like a hippopotamus than a modern rhino. And based on this description, Teleoceras, Henry Fifield Osborne, who described it, suggested in 1898 that it was semi-aquatic and had hippo habitats. But this idea actually persisted for almost a century, but has recently been discounted because of evidence in isotopic evidence because of their hands. So some species of Teleoceras have small nasal horns, but it appears to be absent in other species like Aposoma. They've also got high-crowned or hypsodont teeth, which historically led to the species being grazers, but dental microwear and mesowear analysis suggests they had mixed feeding, so they would eat both browse. They would both browse and graze. And the carbon isotopes suggest they would have, and tooth suggest they were kind of grazing like hippos, but they didn't use water like hippos, which is also quite interesting. So I mentioned there's quite a few species. I'll see what this one represents. It might have just gone spar, but let's have a look at what this one represents. So Phlogisteter, so that's kind of the more famous one, I believe. Phlogisteter, which is a little one. Which is it's cool. So it probably explains the smaller size as well. There's lots of different species, so they would have come in all sorts of different sizes as well. So you can see about 3 or 5 over your shoulder. That makes sense. I think it still could probably be a little bit bigger though. Let me check again. 1.1 meters. No, that sounds about right. Just because they're so short. There should be about. So it depends on the species, but these guys are a little bit smaller than the rest of them. One thing that's really interesting as well is that this species is quite sexual-dimorphic. So this is the female. So males were larger, those with most mammals, with larger tusks or lower in sizes, and a more massive head and neck, and significantly larger forelimbs. And as a result of biomaturization, females matured and stopped growing before males, which is often seen in extant polygamous animals. So males would have fought for mating rights potentially, with healed wounds on skulls being observed, and healed broken ribs and not uncommon, although none have had their sex determined. This further supported by the breeding age female-to-male ratio in the ashfall fossil beds being 4 to 25 to 1. So 4 males, 25 females, and 1 male. So this also shows a rarity of young adult males preserved at ashfall, which may have accounted if they formed bachelor herds of dominant bulls. So even though it's not this species, there is the famous ashfall fossil beds, which is the most common fossil major, which is the largest species. There's over 100 intact Teleoceras specimens found, and about 20 different genera kind of found, and they seem to be buried at rest after potentially a pyroclastic airfall event, so they would have kind of all been covered and died. And even there's some with like fetuses in their birth canal and things like that, which is quite cool. Most of these skeletons are adult female or young, with a breeding female, as I mentioned before, with a rarity. So if the rhinos in this place resembled a herd, they may have accounted for the young adults, males forming bachelor herds and things like that. The age-varied demographic is actually very similar to modern hippo herds, and among the skeleton, 54% are mature, 30 are young adults, and 16 are older adults. or 16%. The greatest concentration of the ashfall fossils are held in the building called Rhino Barn, due to the prevalence of T major skeletons, which was preserved in a nearly complete state. And one extraordinary specimen shows a calf trying to suckle from its mother, which sadly, didn't happen because it died. But it's still really, really cute little guy. So as I mentioned, there are all sorts of different species. So it does make sense that there's may have been some that are a little bit smaller. So Fossiter may have been a bit smaller. But yeah, there is so many different species. So I imagine there was some like Pronotum would have gotten quite large. But I'm not sure about this species, but I think it could be described as a little bit bigger. Let me quickly check. Yeah, Fossiter was quite small, so that is, yeah, that makes sense. Yeah, that's correct. Correct sizing, very good. It's a cute little guy. Nice to see, and the cute little baby. Is that ever got? He should be on, yeah. See the little juvenile there. Anyway, so that's done by Leif and Nicholas Lion Rider. So this one is also done by Leif and Nicholas Lion Rider. We have got here Deinotherium. So this is one I've covered recently in Jurassic World Evolution, but now we've finally got it in Planet Zoo by Leif and Nicholas Lion Rider again. So Deinotherium, these guys are an extinct genus of large elephant-like proboscideans that lived from around the Middle Miocene to the Pleistocene, and this is the species Giganteum, as it's described in the thing. So it is kind of it's the type species and potentially the largest. So one of the things that really sets a Deinotherium apart from modern elephants is its head. It's got downward curving tusks from its chin and a much smaller trunk, and actually had a much more flexible neck and actually different kind of legs that suggested it had much more of a cursorial lifestyle. So it would have lived quite a different life than a modern elephant. And they were quite a widespread genus, and they were found in East Africa, north to southern Europe, and into India. So they had quite a wide range, and they were thought to be browsing animals feeding on leaves, and they likely went extinct due to climatic changes with a lot of their forests that they relied on turning into grasslands during the later half of the Aegean. And they survived the longest in Africa, so they would have lived in Africa right until the early Pleistocene, so about 2 million years ago or so. So they did have quite a good run. And Deinotherium has quite a long history in terms of its description. First of them were found in the 17th century, where they had found a large amount of animals in the Field of Giants. And they actually first suggested these bones were similar to a mammoth, and then in the 18th and early 19th century, George Cuvier, who was like the father of paleontology, actually thought these guys may have been a large tapir or a sirenian, which is quite interesting. But the genus itself, Deinotherium, was coined in 1829 by Johann Jacob von Kamp, who described a fossil skull and mandible from Germany. And the type species, which is this species, Giganteum, was the first kind of thought to be the evolutionary link between sloths and mastodons, which is very erroneous or not true. Further remains discovered and named to suggest they would have been considered part of the genus Prodeinotherium, and these additional remains suggest that Deinotherium's position within Proboscidea and finds an India described as the Indicum extended the genus range outside of Europe. And fossils of extremely large specimens in Romania were kind of described. And there's a few different species that have been described that they've all kind of been lumped into a few that are kind of standing today. So the main ones is like Boiso, Giganteum, and Indicum. So those are the kind of main ones, but there is a few more that could be described. In terms of their name, Deinotherium comes from ancient Greek, which means terrible beast. And some authors originally referred to Deinotherium as Deinotherium, like dinosaurs. But it seems to be Deinotherium is the correct spelling. So in terms of their kind of anatomy and description, these guys were quite large-bodied proboscideans that displayed continued growth between species. So 2 adult males of D. giganteum were about 3.6 to 4 meters, or about 11 to 13 feet tall at the shoulder, and weighed between 8.8 and 12 tons. And this is similar to a few other species like Provarum, and things like that. There are some smaller specimens, like about 4.1 meters at 13 tons. So those are kind of the later ones. The most recent species, which died at the Pleistocene, was about 3.6 meters or 12 feet tall and about 13 tons. So comparable in size pretty much to a large bull African elephant, or maybe a little bit bigger. So not too different in size, or not something that we can't comprehend. Quite similar in that regard. The general anatomy of Deinotherium is similar to that of modern elephants, with pillar-like limbs, although proportionally longer and more slender, so they had much longer, slender legs than other proboscideans. And the bones of the toes were actually longer and less robust than other elephants, and their neck was likely also relatively longer and more flexible, though it was nowhere near as long, and they're actually quite short still compared to other modern browsers like giraffes, which is quite interesting. So in terms of their teeth, they have the tooth formula of 0023 with tooth replacement, and they have biphyllodont and triphyllodont teeth, and they had vertical shearing kind of teeth, which was actually suggests that Deinotherium may have been an independent evolutionary branch early on, with the other premolars used for crushing. So they actually have a long, short, long, flattened top on their head compared to more advanced proboscideans, which have more domed foreheads. And the largest skulls of Deinotherium reach about 120 to 130 centimeters long, or 47 to 51 inches. The nails opening also is large, indicate that it had a large trunk, though it says soft tissue, so we don't have an exact idea of how long it would have been, though I think this is a little bit of a short interpretation. And the rostral was as long and had the rostral fossa beads and, the really long curve downwards with these backward curving tusks, quite distinctive of Deinotherium. So these tusks were without the most interesting part of them, and unlike modern proboscideans, they have tusks that grow from upper incisors. These guys were actually grown from the lower incisors and lower canines, with the upper incisors and upper and lower canines missing entirely. And the curvature is initially formed by the mandible itself, with the teeth erupting only halfway the point of the curve, and the degree of which tusks follow the direction predetermined by the mandible varies between some specimens, with some tusks following the curve and going backwards in a semicircular shape, with others seeming to be almost vertical. So it just depends. Elephant tusks are quite varied, so these Deinotherium may have had quite varied tusks as well. And although the presence of an elephant-like proboscis in the trunk is evident by the size and shape of the nares, the exact shape of the trunk is a matter that has long been debated. Historic depictions should portray them as very elephantine with long trunks and tusks breaking through the skin of the elephantine lower lips. But some early research has actually been looking to the soft tissue, and they argue that the lower lip should be situated beneath them and kind of with their down-to-earth appearance. They also further suggest with the trunk it would have been present, it would have not really looked like an elephant trunk. It would have been more robust and muscular, and which is their reasoning is evidenced by the lack of proper insertion. So it would have been shorter and more like muscular and not quite as long. And the idea of although later research concurs with these guys would have had different trunks than modern elephants, the idea of a short tapir trunk may have been in question. And it was also pointed out that because of their tall stature, being quite tall animals and still having short necks, they would have been very difficult for them to drink without having a trunk that was at least long enough to reach the ground. So I think this is, in terms of this particular interpretation, this trunk might be a little bit small, but something a little bit longer, maybe half as long again, would be something that fits for Deinotherium. So as I mentioned, there is, during its time of being described, there's been about 31 different species described, and there's been a lot of them are poorly sampled, but the amount of species has kind of gone down. But the three species most considered the most are kind of the best described. There's Bolzani from East Africa that lived about 1 million years ago in Kenya during the early Pleistocene. And these guys were actually smaller than the European species. So this suggests that actually this might be Allen's rule. So animals from lower latitudes, so more closer to the tropics, would have been smaller than animals at higher latitudes, such in Europe and things like that. So probably better to conserve body heat. Though, however, this actually suggests that it may be a cause of parallel evolution, and it may have actually been a response to acidification with Africa becoming drier. And this species here is based on Gigantium. So Gigantium was found in Europe in the middle Miocene to early Pliocene. However, its extinction is unknown. It lived around Central and Western Europe, where the materials in Russia may have actually extended their range up there. And it was also found in the island of Crete from the Upper Miocene. And but at that time it would have been connected for the mainland, so there's not any dwarf Deinotherium, I'm sorry. And then the species Indicum, which is far more robust and found around the Indian subcontinent, and it disappeared from the fossil record about 7 million years ago. Although it typically is regarded as valid, is considered to be synonymous with the species Deinotherium procavan, and later would be named. So there's a couple other species that have been described and included, like Gigantatissimus procavum and things like that, but have all been kind of lumped. But yeah, these guys had quite a wide range. They lived in East Africa, into Europe, and into South and East Asia. And European fossils are especially common around the southeast, with about half known specimens coming from Bulgaria. So there's a lot of, some from Indian subcontinent, and even though they may not be different species, it's just like a lot of specimens from around the world, especially like around East Asia, places like that. So quite a wide range. So we'll talk a little bit about their evolution while we have a look at these cute little babies. How cute is this little guy? How cute, I love it. Anyway, the origin of Deinotherium can be found in the Oligocene from Africa with the small-bodied Chicalotherium. So they were initially restricted to Africa. They continued northward from the African plate by the proboscidean Duntum event, and during which they actually managed to spread into Eurasia and diversify, along with the ancestral Pro-Deinotherium, which was thought to be the direct ancestor to Deinotherium. And generally, they display little change actually in their morphology throughout its evolution, but a steady increase of body size from the 2-meter shoulder height of Pro-Deinotherium to the 4-meter shoulder height of Deinotherium proper, which was a mass far exceeding even large African elephants. So they would have been a little bit larger than large African elephants today, and up there with some of the biggest bulls. The reasons for this rapid increase in body size may have been attributed by multiple factors. Larger size could be a good deterrent against predators, such as hyenodonts, amphicyonids, and large cats. Otherwise, considered acidification would have split up woodlands, which means they'd have to walk more to get to woodland patches. And this also accounts for their limbs, which are really cursorially adapted for long travel, like traveling long areas. Ooh, that's not what I meant to click. I'll look at the male again, since we've had a look at the cute little baby. And also Bergman's rule, with getting bigger in higher latitudes means they could better conserve body heat. And a lot of these, despite these many key adaptations they developed for foraging, the continued acidification from in the Miocene actually led to their extinction of the group, which failed to get their food sources, because being browsers with grassland spreading, there's less woodlands and less trees to support a large browser like Deinotherium. And populations in Western Europe at first to disappear, and then late in Europe, and then they kind of held out until into Africa until the early Pleistocene, about 1 million years ago, with the last known species being Borzoi, which died in the Pleistocene. So in terms of its paleoecology, as I mentioned, we do know there was a lot of key adaptations that these guys were folivores, so eating, browsing, and feeding on the tree canopy. And in Asia, they've actually been associated with wet and warm low-energy woodlands, and in Portugal they would have been in moist kind of subtropical to tropical woodland conditions likened to the modern Sengals. So by the time they were kind of alive, especially around the Pliocene, the world was a little bit warmer and there were a lot more wetlands and woodlands, so that's kind of allowed them to survive. A browsing lifestyle is also supported by Deinotherium's slightly more raised head posture and its teeth, which are strongly resemblant of modern tapirs, which are all browsers that feed on fruit, flowers, barks, and leaves. But there's also the limbs show some notable differences to Pro-Deinotherium, which allow them for more agile locomotion and easier transport, so it can walk around better to larger, wider locations and things like that around the landscape. And concludes with the widespread breakup of forests and the expansion of grasslands during the Deinotherium's time in Europe. Fossils also finds in Austrian and Gothic locations suggest they would have been not permanent residents and would have been migratory, so they would have traversed areas on a regular basis. And there's also evidence of animals range shifting with changing climate conditions, and during subtropical climate conditions and more subboreal conditions, and being absent in subboreal conditions. So as the world kind of got cooler, there would have been less, nice plants for them to eat, nice trees, like the woodland habitats they preferred, so their range restricted more and more until they went extinct in southern Africa about 1 million years ago. And one of the most enigmatic features of Deinotherium is you can see their down-turned tusk, and everyone was like, what are their tusks for? But research has actually conducted on Deinotherium suggests they were not used for digging, nor were they sexually dimorphic, so males and females both had them. They were used in feeding, and most likely leaving use of feeding most likely function. And the tusks actually have wear patterns on them that suggest on their medial and carpal size that suggest they would have used them to remove bark that would have gotten in the way of them feeding, and would have been used by proboscideans to kind of the proboscis to transport leaf material into their mouth. So they would have able to just, kind of use it to break up branches and things to kind of better eat the branches and things like that. And then Deinotherium would have had a powerful tongue, which is inferred based on the notable trough in the front of the symbiosis, to further manipulate their food. And different tusk anatomy and young individuals suggest they would have had altered feeding strategies as juveniles. So that's quite interesting. That kind of shows that they had a very different ecology to modern elephants, and once kind of that niche didn't exist anymore, they sadly went extinct. But still a really wonderful animal, and Deinotheriums are just a really, really cool animal. Really interesting shape. And Leaf and Nick did a great job of showing off this really cool animal. I'm definitely a big fan. So let's let you run off and do your thing. So last off, we've got another one by Leaf and Nicholas Lionrider. So this one is kind of remade by Nuto's mod, but has been edited a lot. We've got Smilodon fatalis. So really, really cool. So we'll talk about these guys. So this is Smilodon fatalis. So Smilodon itself is an extinct genus of felid and one of the best known, saber-toothed cats or prehistoric mammals. And they were commonly known as the saber-toothed tiger. They are not related to tigers at all, and they belong to the extinct group, the Americarodontidae, which is a group of cats that diverged from modern cats about 20 million years ago, and was one of the last surviving Macarodonts, along with Homotherium, and lived to America potentially about 12,000 years ago, 10,000 years ago. The genus was named in 1842 based on fossils from Brazil, and which means scalpel or two-edged knife, or like the knife tooth. And 3 species have been recognized. This one's fatalis, but there's also gracilis and populata. We'll probably just talk about fatalis at the moment, but I will mention populata and things like that. They are believed to have both species fatalis and populata were thought to descend from gracilis, which evolved from Meganteron. And hundreds of specimens have been found of fatalis in the La Brea tar pits. So that has the largest collection of fossils, which is quite cool. So as I mentioned, they were first described then. The fossils of Smilodon in North America, because fatalis is only found in North America, while populata lived in South America. They were found from the 19th century onwards, and found with the maxilla and molar, and they were originally Felis fatalis, but then when combined into Smilodon. And La Brea tar pits has thousands of these specimens, and they've still been collecting them. So you have quite a good idea about the anatomy and everything about Smilodon. And they were actually split into species Californiensis, potentially. But there's not enough evidence to really support that yet, and, all those things like that. And the third species is gracilis, as I mentioned, populata from South America, much bigger. But in terms of their evolution, long the most completely known saber-toothed cat, Smilodon is one of the best members of the group. And the term saber-tooth actually refers to an ecomorph of predators, things like synapsids, so things like Gorgonopsians, Thylacosmilus, Nemravids, Barbophilus, and Macarodonts all kind of had these large canine teeth used to kill prey, and they all potentially use their canine teeth differently, but we'll get into a little bit about how they would have used theirs. And despite the common name, as I mentioned, saber-toothed tiger, they're not actually closely related to modern tigers at all. And they are actually in their own group, Macarodontidae. They are related to animals such as Meganteron, Homotherium, Macarodus, and Deinotherium, and Remparvis, and things like that. The earliest felids from the Oligocene of Europe, such as Polaris, which are thought to be similar. And the first earliest saber-tooths were actually thought to be more similar to the modern cow leopard in terms of its anatomy, and then they would have kind of evolved into these more derived ones, which have become shortened and bigger and much more bear-like as well. And even the Homotherium was actually quite interesting. So they were once the dominant felids distributed across Africa and Eurasia and in North America during the Miocene and Pleistocene, but they declined over the course of the Pleistocene, and by the late Pleistocene there were only 2 genera of Macarodonts, with Smilodon living in the Americas and Homotherium living across Eurasia and America, and even potentially into South America, which is quite interesting. The earliest species, as mentioned, was gracilis, which existed from 2.5 million to 500,000 years ago, which was the successor of the North American of Meganteron, which lived in kind of North America about 2 million years ago, along with Homotherium. And then gracilis fatalis would have existed between 1.6 million to 10,000 years ago, and which replaced Gracilis in America, and then North America, and then Spopolyta would have lived between 1 million to 10,000 years ago and lived in South America. So in terms of their skeleton, they were about the same size as modern big cats, but much more robustly built. They had reduced lumbar, high scapulars, short tail, and looked more bear-like, so they're much more heavily built and more adapted for taking down larger prey. They are most famous for their relatively long canines, with the longest being about 28 centimeters, or about 11 inches in Populata. And these canines were quite fine in serrations and quite from the front to back sides, and the skull was robustly positioned in around the muzzle and short and broad, and these kind of cheekbones were deeply and wide arched as well. And there's also some evidence suggests from La Brea that there is some dispute whether Smilodon itself was sexually dimorphic. And some studies of Phytalis suggest there was not many differences between the sexes. And conversely, there was a 2012 study that suggests that they show less variation in size among individuals than one of Panthera, and they do appear to show some of the same difference between the sexes in some traits. So there's not much of a size difference between them, but they do share a lot of traits that can tell male and female apart. So Gracilis was the smallest of the species, being the earliest, being about 55 to 100 kilograms, or about 121 to 220 pounds, about the size of a jaguar. And then Phytalis was kind of in between that size. So Phytalis would have got between 160 to 280 kilograms, or between 350 to 620 pounds, and reached a shoulder height of about 100 centimeters, or 39 inches, and 175 centimeters in body length, which was very similar to a lion in body dimensions, but potentially a little bit more robust and heavier. And they also would have had a skull quite similar to Meganterion, with more massive canines. And then you have the largest one of all, Populata, which was among the largest known felids, with a body mass that ranged from 220 kilograms or 490 pounds to over 400 kilograms to 899 pounds, with one estimate even suggesting they may have got up to 470 kilograms or up to just over 1,000 pounds, with them being kind of largest and more adept for killing, large things down in South America. They were a little bit more the apex predators, while Phytalis would have had to compete with things like American lions and dire wolves, which is quite interesting. So external features, there have been some research into potentially what their colours were like, with plain coats and things like that, and some of the feeler forms. And there has been a relationship to suggest that some that are open area cats used to usually have more uniform colours, whilst they have more markings if they live in forested areas, which makes sense for Phytalis, because Phytalis this one is based more on a clouded leopard, which is believed to be a little bit more of a forest species, and Phytalis would have been a little bit more forested in comparison to Populata, which would be more open areas. So that's quite interesting. And traditionally, they have been reconstructed with features similar to felids, and there's actually been some evidence that suggests they would have had very bulldog long lips, and that kind of came back for a while ago, but it suggests that these guys would have had to be visible from the mouth, because there's no way lips are going to fit around that, and their anatomy suggests that they're kind of like not too different from modern cats, which is quite interesting. The kind of the big bulldog lips idea that was around for a while, and now it suggests they just had normal kind of cat lips, but these guys, their teeth would have stuck out. In terms of their diet, these guys were apex predators. So Smilodon would have hunted large mammals. Isotopes preserved in S. Phytalis from the tar pits suggest they would have eaten things like bison, camels, and things as well, with Phytalis actually also occasionally preying upon Deinotherium, things like that. Gracilis would have been fed on peccaries and llama-like animals, and these guys would have shown. And also isotope studies looking at dire wolves and American lions actually show an overlap with Phytalis in terms of prey choice. So they would have competed with American lions and dire wolves in North America, for prey. And more detailed isotopes, however, show that Smilodon Phytalis would have preferred forest-dwelling plains such as tapirs, deer, and forest-dwelling bison, while the dire wolves would have preferred grasslands and things like that. And the availability of prey was likely comparable to modern East Africa, so there would have been a lot of animals to eat and a lot of meat to go around. In terms of, as Smilodon would have migrated into South America, bison were absent, and the horses and proboscideans were different, and the native ungulates were things like toxodonts and macrochenia, and yet Smilodon Populata actually survived quite well. So isotopes suggest that Populata, the South American larger species, would have been feeding on things such as toxodon, Amastelia, Paleo-Lama types of horses, and caiman as well, which is quite interesting. And this actually indicates that these guys would have lived in more open habitats compared to Fatalis' more closed habitats. There's also coprolites from... There's also a difference in North American species, maybe difference of prey. And Smilodon may have avoided eating bone when they had left enough food for scavengers. And coprolites that have been assigned to popular tags suggest they would have had Mylodon, osteoderms, and a laminar scapulocoid bone, which suggests they would have eaten consumption, but they believe they have a more generous diet than previously thought. And they would have eaten both flesh and bone, and particularly would have even scavenged direwolf kills. So in terms of predator behavior, there's been a lot of research on how they would have killed their prey and used their teeth. We're actually going to have a look at the cute little babies, I think. We'll have a look at the cute little baby. Is this an adult? No, we want to have a look at the baby. We'll talk a little bit about the babies as well very soon. Anyway, so the brains of Smilodon have schuylkill patterns, similar to modern cats. They would have preyed. They had good binocular vision, and just like modern cats, even though they had relatively small eyes, but they would have had good binocular vision, and they likely would have been ambush predators. So they would have been relying more on hunting prey. They also would have had plantigrade feet, allowed them to be a bit more stronger in that regard, and a little less adapted for running. The heel bone of Smilodon was fairly long, suggests it was a good jumper, and had well-developed flexors and things like that to be able to pull down and securely hold on to large prey. And how they would have attacked prey is kind of open their mouth. They would have stabbed into their throat, which would have killed the prey going through the jugular and the windpipe, doing it in one go. And that's pretty much the most common interpretation of how they would have killed prey, using the canine shear bite kind of hypothesis. However, evidence from Deinotherium suggests they would have been pretty able to kind of utilize these canine shearing bites and kill prey, despite the fact they had little skulls. So this is Deinotherium, the relative. But there have been lots of evidence, and there's even like a mechanical one that stimulates the neck and jaws of Fatalis on bison out carcasses. So they would have been quite able to go for the neck. That's where they would have preferred to go to, like modern predators typically do. So yeah, they would have used their long teeth to kind of pin it. They would pin the animal down with their large arms, bite the neck with their saber teeth, and go through the jugular and windpipe, and kind of kill them as quickly as possible. So they would have been able to use that to stabilize their prey as well. And looking at evidence, they would have had proportionally weaker bites than other species of big cats. So modern big cats have more pronounced zygomatic arches, which had larger muscles. These guys would have had slightly weaker muscles. It still would have been quite strong, but it would have only been about the third of a lion. But these guys would have also had a much wider gap that allows them to get their canines over the animal's neck and bite down into their jaws. So they were still quite powerful. It was just a different way of hunting, and they seem to be quite well adapted to doing it for their large size. And there have been, because of the La Brea tar pits, we do have quite a good idea of, because we have believed about 10,000, over 166,000 Smilodon fatalis specimens, which is a huge amount of specimens, and so that's why we know so much about Smilodon, especially being an extinct animal, which is interesting. And there's also the Talamar tar pits in Peru that have a similar kind of situation. They have Smilodon popular tar, and they would have been trapped in these. So what happens, the tar would have trapped animals that went in there to swim or drink, like large herbivores, and then large herbivores, and then the carnivores would have tried to take their chance to get free meal. They get stuck as well and die. So a lot of these predator traps have a lot more Smilodon, or a lot more carnivores in them compared to herbivores. And there's also been a bit of a debate around the social life of Smilodon. So let's see if we can find another one to talk about. Let's see, look at you. We'll have a look at you, the little cover with the bright colours. Anyway, there's been debates on whether they've been social. There's been studies looking to social behaviours on lions and hyenas. Since fatalis was actually quite common in La Brea tar pits, it's actually likely they were attracted to distress calls, which means they could have been social. And there's lots been claims, non-critical claims to the study suggest other factors such as body mass and things like that. Intelligence and social animals may have avoided the tar, so American lions may have been more social and avoided the tar, things like that. But another argument is actually there is a lot of Smilodon that have had pretty bad injuries that have recovered from them, and they wouldn't have been able to do that without another one looking out for them. And they have relatively small brains compared to other cat species, so they wouldn't have been too dumb, but that's kind of silly. So it's rather debated, but there's no evidence of sexual dimorphism as well, not like modern lions. So a lot of evidence suggests potentially they would have lived socially. In 2021, they did some research into articulated skeletons, which suggests there would have been prolonged parental care in Smilodon. So the two subadults and individuals uncovered share a unique and inherited trait in their dentaries, suggesting they were siblings. And the subadults would actually like to be male and female, so they would have been with their mother. And these subadults were estimated to be about 2 years about their time of death, and still growing. And they would have also had a large hyoid bone, but larger hyoid bone, and would have created more roaring sounds like in cats. The shape was close to those of purring species, so they would have had a really, really deep purr, which is interesting. But also, going back to the sociality, they would have potentially lived in they were suggesting they would have lived in monogamous pairs, or it wouldn't have been something like lions because they don't have these social, they don't have the large social groups or the large size discrepancy between male and female like other social cats like lions. So they potentially would have had a wolf-like sociality, or potentially, monogamous pairs and things like that. We don't know exactly how it looked, but the evidence suggests they did live together in groups, which is quite interesting. There's also research and development, which is really interesting. Smilodon would actually start to develop its adult saber teeth between 12 and 19 months of age, where they would have kind of erupted from their baby teeth. And it would have been present for the side of the mouth about 11-month period. And once they would reach about 23 to 30 months of age, these infant teeth would have shed, and the adult teeth would have come out in the 12-month period. And they reach their full adult size at 3 years old, which is later than most species of big cat. In juvenile and adult adolescent Smilodon would have been extremely rare in Russia La Brea. And when the species study was born, indicating they remained hidden in dens or sites during hunts and depended on parental care. There's actually a study on 2024 that actually suggested adolescent Smilodon actually kept their milk sabers for extended periods to help reinforce their adult canines as they grew. So they would have supported them and helped, make sure they not break. But this would also look like very interesting. They would have looked like double-fanged during this growth stage. And in 2017, there was some research looking into the juveniles. So they were born in a robust build more similar to the adults, and bones from juveniles fatalis were compared with those that American lions suggest they shared a familiar growth curve. And felines forelum suggested during ontogeny they would have remained tightly constrained. The curve is similar to those of modern big cats such as tigers or cougars, but shifts more in the robust direction that is seen as modern felids. And also some evidence suggests that they would have had unique and quite fast growth rates similar to that of a tiger, but it would have been prolonged, so very similar to what to see on lions, and babies would have been very reliant on their parents until that growth period ended. So likely a mother Smilodon would have to deal with their kids for 2 to 3 years, which is also probably a knock to them being social, because that's a long time to take care of your babies. So that's another knock on their belt to potentially being social. Also, lots of paleopathologies, lots of injuries, things like that, potentially coming from animals, colliding with prey or other Smilodon. A lot of injuries. Since we have such a large sample size, we have a lot of different injuries and things like that. Also, potentially some defects from being inbred as well, which is quite interesting. But anyway, we'll keep talking about them. So in terms of their habitat and things like that, these guys would have lived during the Pleistocene, about 2.5 to 10,000 years ago, and would have been the most recent of the saber-tooths. Vitalis would have lived in a variety of habitats, including open grasslands and parklands and woodland areas and closed forests. And fossils have been found throughout South America North America from Vitalis, from about Alberta, Canada, and Smilodon itself, with the southernmost being from Southwest Patagonia. The habitats of North America were varied. There was mammoth steppe to the north, and lots of mosaic habitats and shrubs and woodlands and grasses to southeast, where Vitalis would have lived in more, closed areas, living with animals such as antelope, bison, horses, mammoths, mastodons, ground sloths, camels, and things like that. And North America would have also supported other saber-toothed cats such as Deinotherium and Cynosmilis, along with direwolves, short-faced bears, and American lions. And competition from these other species would have prevented Vitalis to get to the same size as Populatar, and the similarity in size to S. Vitalis and the American lion suggests they would have directly competed with each other and fed on different prey. So the absence of American lions and most direwolves for the most part in direwolves are found in South America too, but Populatar kind of was the only one that the big predator in South America, while Fatalis had to deal with American lions, which were bigger. Gracilis would have entered South America during the early to mid Pleistocene, which would have given rise to Populatar. And there was 2 species thought to live in the Andes Mountains. So there was a skull of Fatalis found in Uruguay that suggests the 2 species were reported. They actually weren't geographically separated, so potentially they would have been more niche separated. So closed habitats would have been founded for Fatalis, and open habitats would have been more for Populatar in South America. So as I mentioned, there was Uruguay, so which is South America. That's really cool. The American interchange would have resulted in a mix of native introduced species getting spread from North and South America. So you would have had toxodonts and glyptodonts and ground sloths living in North America, while you had horses and elephants and tapirs coming down into South America, which is quite interesting. Populatar was actually very successful too, while Homotherium never became widespread in South America. The extinction of Thylacophilans may have been attributed to Smilodon, but that is probably incorrect. And the forest arachids may have dominated that large perch niche until Smilodon arrived. And Smilodon may have actually been able to reach larger sizes than S. fatalis because of lacking competition in the Pleistocene South America. And S. populatar actually arrived after the extinction of Deinotherium augustidens, which was one of the largest megacarnivores, like a giant, huge animal, potentially over a ton or more. And they would have took that niche as megacarnivore. And Populatar preferred large prey on the grasslands and plains and gathered from isotopes. In this way, South American Smilodon would have been similar to modern lions, and they would have probably competed with the canine Procyonon, but not with jaguars, who preferred smaller prey, which is quite interesting. And as I mentioned, we did have Fatalis potentially from Uruguay, which is in South America. So they may have Fatalis may have lived in North America too, but potentially would have kind of niche partitions, so they would have lived in more forested areas, while Populatar would have lived in more open areas. But in terms of their extinction, this is something that's very often talked about. Along with most of the Pleistocene megafauna in North and South America, they went extinct about 10,000 years ago. And this is likely, there's been debates about it, we've talked about it as well. Whether it was humans or climate change, whatever it is, it caused the large megafauna to decline. And since these both species of Smilodon were well adapted for killing large animals, with no large animals around, there was no food around, and since they were so specialized to large prey, they would have gone extinct due to no food. And the youngest kind of radiocarbon dates actually for Fatalis and Populatar are actually quite different. So Fatalis would have lived to the died out just before the Langur dry ice event, and the Populatar may have actually lived to early Holocene. So the La Brea ones would have lived around, potentially went extinct about 13,000 years ago, while potentially the southern species of Fatalis may have lived about 11,000 years ago. And however, such radiation, may have been properly calibrated, but there are actually specimens from Regala Fatalis which may have been younger, which is quite interesting. But also as well, within the first half, these kind of more specialized saber-toothed cats like Homotherium became extinct because of the competition for more generalized felids that replaced them. So things like cougars and things like that, and other specialized big carnivores like the American lion and the American cheetah or Monoactrox actually became extinct in late Pleistocene, as well as their more specialized prey went extinct. And as I mentioned, it could be climate change that caused the megafauna to decline, could be humans, could be a combination of the factors. It's a very complicated topic, we don't have the time to go into it. But anyway, so I think this is a great place to end the video. So really great to see everyone, Leaf and Nicholas Linerider, Scott and Monsoon, they all did wonderful jobs. So hope you guys enjoyed this video, hope you guys like and subscribe. Always remember to hit the little bell icon to get notified about anything. So hope you guys enjoyed this video, hope you guys like and subscribe, and bye bye.